8.5 Solubility and Saturation. Table 1 shows the solubility of common solutes in water at 20 degrees Celsius. And you'll notice that the various compounds have various solubility, the amount of a substance that can completely dissolve in 100 grams of water at 20 degrees Celsius. Let's define some important terms. A saturated solution is a solution that contains the maximum quantity of a solute at a given temperature and pressure. An unsaturated solution is a solution in which more solute can dissolve at a given temperature and pressure. And a supersaturated solution is a solution that contains more than the maximum quantity of a solute that it should hold at a given temperature and pressure. Take a look at this figure. This figure shows the solubility in grams per 100 grams of water of various substances at various temperatures. And we can use this table to determine the type of solution that will form for a given amount at a given temperature for different compounds. Points directly on the curve represent a saturated solution. Points below the curve represent unsaturated solutions. The vertical difference between a point below the curve and a point on the curve represents the additional mass of solute per 100 grams required to saturate the solution at that temperature. Points above the curve represent supersaturated solutions, and the vertical difference is a point above the curve and a point on the curve, which represents the mass of the solute per 100 grams of water that will crystallize out of the solution at that temperature. Note, supersaturated solutions are prepared by dissolving a solute in water at high temperature where its solubility increases and then allowing the solution to cool. Any additional amount of solute after cooling will cause the excess solute to crystallize out of the solution. Let's use the graph for solubility to answer the following questions. Question number 1. Calculate a solution that contains 60 grams per 100 grams of water of potassium nitrate at 40 degrees Celsius as a saturated, unsaturated, or supersaturated solution. So let's find potassium nitrate at 40 degrees and see if the amount at 40 degrees is greater than, equal to, or less than 60 grams per 100 gram. So we're looking for potassium nitrate at 40 degrees. This is the curve for potassium nitrate. And at 40 degrees, this is the curve for potassium nitrate. And at 40 degrees, in order to be a saturated solution, you would have to have roughly 65 grams per 100 grams of water. So if we only add 60 grams, then this will be an unsaturated solution because it's less than 65 grams per 100 grams of water. Question number 2. What mass of solute is required to saturate a solution containing 10 grams per 100 grams of water of sodium chloride at 30 degrees Celsius? So the solution already contains 10 grams, we need to know how much more we have to add at 30 degrees of sodium chloride in order to make it saturated. Let's find out the saturation level of sodium chloride at 30 degrees. This is the curve for sodium chloride. And at 30 degrees, the saturation is about 38 grams per 100 grams of water in order to be saturated. If the solution already contains 10 grams, (38 grams) minus the 10 grams it already contains, we need to add 28 grams of NaCl in order to saturate a solution. Question number 3. At what temperature does a solution containing 50 grams of potassium chlorate become saturated? So let's find potassium chlorate and see at what temperature 50 grams will be saturated. So here is the curve for potassium chlorate. And we're going to see 50 grams where it connects with potassium chlorate. And it looks like it will be saturated between 90 and 95 degrees Celsius. Now let's take a look at the solubility curves of gases. Unlike with solids, the solubility of gases decreases as the temperature rises. So as temperature increases, solubility decreases. The trend in solubility for oxygen means that cold water contains more oxygen than warm water. Let's define pressure. Pressure is the force applied to a unit area. Pressure has little effect on solids and liquids because these states are not very compressible. Gases, however, are significantly affected by changes in pressure. In particular, the solubility of a gas in a liquid increases as the pressure of the gas is increased. This is important for aquatic animals. The lack of oxygen in warm water can be extremely stressful on fish, equivalent to suffocation. This explains why fish are more likely to be found in deeper, cooler water than near the surface. This also explains soft drinks. Soft drink manufacturers use the property of pressure to dissolve far more CO2 in pop than it can hold at normal atmospheric conditions. Chilling the drinks while they are being carbonated also helps more of the gas dissolve. There are no gas bubbles in a sealed bottle of pop because the pressurized gas above the surface keeps the CO2 dissolved in the liquid. Opening the bottle reduces the pressure. This decreases the solubility of CO2, causing the sudden increase or release of carbon dioxide bubbles. The release of bubbles proves that pop contains more dissolved carbon dioxide than it should. A carbonated drink is an example of a supersaturated solution. Please try any homework problems assigned and any LMS quizzes on this section.